All right, welcome to lesson 3.10. Here we're going to continue solving rational equations in context, and we're going to solve them again with algebraic methods by hand as well as graphically, and we're going to continue practicing writing these equations to model these particular situations. In order to write equations both efficiently and correctly, we're going to want to take advantage of real-world relationships or equations that are both very powerful and very simple. So go ahead and write down as many relationships or equations as you can between each of these sets of things. So to start off with distance traveled, speed, and time. And you want to give each of these a variable name. You might go lowercase d, lowercase s, and lowercase t, and write as many equations as you can that involve these three variables. And then do that for each of these 5 sets. And you might find that you can write more than one equation for a given set, and so go ahead and do so. And then we'll go ahead and take a look at them and see how these might be useful moving forward. All right, the first one should be a piece of cake. The distance that you travel is going to be equal to the speed that you traveled at multiplied by the time that you traveled at that speed for. And using this equation as a jumping off point, we can then solve for time by dividing on both sides by the speed, and we can solve for the speed by dividing on both sides by the time. Now, it's usually helpful to have a real-world example just to help you kind of remember why this makes sense. So what I like to do is just imagine I'm traveling 5 miles per hour for 2 hours. What would I do to find the total distance? And then do the same thing and say, okay, if that was my total distance, say I traveled 10 miles at a speed of 5 miles per hour, oh, that's right, I'll be traveling for 2 hours. And similarly, if you travel 10 miles in 2 hours, you're right, that's 5 miles per hour. Analogously, we have the relationship between work, rate, and time. And this is a more general situation. This is very specific, right? But this is kind of the same equation, just in a more general way. The amount of work that I get done is going to be equal to the rate at which I'm working times the time for which I work. And similarly, I can solve for time and for rate. Let's come up with an example in context that you could write down that would help you to remember this relationship. Let's say that the work that we're doing is we're laying bricks. And let's say that I can lay 7 bricks per minute. Well, that would mean that if I worked for, say, 10 minutes, I would be able to lay 7 times 10, or 70 bricks. And you can take this and use it in each of these equations as well to think about how laying 70 bricks at a rate of 7 bricks per minute would get you a total time of 10 minutes. And similarly, if you lay 70 bricks in 10 minutes, you're going to be laying bricks at a rate of 7 bricks per minute. And we can apply this to any type of work that's being done. Now, within these, there is also a way to represent time, work, and distance that are broken up into different steps. So let's take a look at those. Okay, so these are pretty obvious, but they come in handy, and I'll explain a little bit why. If you take a certain amount of time to go somewhere, a certain amount of time to go back, then the time that it took in total is going to be time to go there plus the time to go back. Pretty straightforward. Similarly, if you're doing some task with someone else or multiple people, the amount of work that you do plus the amount of work that the other person does is going to add up to be the amount of work that's done in total. Similarly, if you travel a certain distance in one direction and then a certain distance in another direction, the total distance that you've traveled is the sum of those two. Now, because we know how to calculate distance, work, time independently, we can then use these to write a bigger equation, right? So we need to make sure that we are always thinking about these relationships and that when we go and we actually annotate a question, we are looking to find a distance, a time, an amount of work, a rate, so that we can create an equation that will allow us to solve for the variable that we seek. So you'll want to leave a little bit of space here in your notebook because we'll add on to this as we go on. There will be a couple of other relationships that we can take advantage of. Now that we have a clear understanding of those simple real-world relationships. When we go to solve word problems, we can utilize these in order to write equations that will benefit us. In other words, an equation that will include the variable that we're trying to solve for so that we can then solve that equation. So the one thing that I want to highlight is that as you're going through and annotating your problem, you're obviously looking to identify what you're trying to find. What is that variable? Maybe you have to give it a variable name. But as you're looking at what you know, in other words, all the information that the problem gives you, you'll want to label this in a meaningful way. So for example, if it tells you a piece of information about how many bricks Jorge can lay per minute, you want to recognize that as a rate. And so you want to label it accordingly so that when you go to create your plan and you look to perhaps write an equation, you can understand the relationship that you're going to use. Now, lastly, I just want to mention that this is not unique to word problems that involve rational equations, but it can be the case that equations that are represented with rational expressions can sometimes be a little more complex. So this is a general strategy that we have, but we really need to make sure we're sound in it because these problems can be trickier if we don't implement the strategy correctly. Okay, so here's the question that we have talked about, and I've taken out the equation that they gave us. So your goal is to reread the question, write it down again, and go through and annotate what are you trying to find, what is the variable that represents it, and then with each piece of information that you're given, try and figure out, is it an amount of work that's done, is that representing a rate, is it representing a time, and then once you've done so, go ahead and try to write an equation that you could solve for the variable that you are trying to find. Okay, let's go through it together now. So my strategy, I'm going to read the question all the way through first, and then I'm going to go back and I'm going to annotate, trying to be as specific as possible about each piece and what it tells me. After reading the whole thing, I'm going to first identify what it is I'm trying to find. That, of course, is the value of t, how many minutes it will take Antoine to solve the problem by himself. Now going back through each piece of information, I can label it correctly with regards to what it represents. The first thing I notice is that it tells me that Mary requires 16 minutes more than Antoine to solve a single puzzle. So this actually tells me the rate at which Mary can solve a puzzle, and her rate is one puzzle per t plus 16 minutes. Remember, rate is an amount of something done per an amount of time. Right, next, I'm going to jump actually to the rate at which Antoine can solve a puzzle because we just talked about the rate at which Mary can solve a puzzle. And notice here that it says he can solve a puzzle in t minutes. So his rate is one puzzle every t minutes, or 1 over t puzzles per minute. All right, the next piece of information that I'm given is their combined rate. Right? Together, they can solve a puzzle in 6 minutes. So I'm going to label that there as 1/6 puzzles per minute, and that is their rate combined. Now I'm ready to go ahead and write my equation. There's actually a couple of different ways that you could write this equation, and I'm going to focus on one that I think makes the most sense and is the most widely applicable. So notice, of course, that I don't have an equation that correlates explicitly someone's rate, another person's rate, and then, for example, sets their sum equal to their combined rate. I don't have that. But I do know that the work that one person gets done plus the work that the other person gets done will equal the total amount of work that they get done together. Now notice that to figure out how much work each person's getting done, I'm going to need their rate, which I have, and I'm going to need the amount of time that they work for, which I know. So one of the things that can be helpful is to go ahead and write out in words what my equation will be, and then go ahead and put in place of those words the mathematical symbols that we will need. Okay, so here I've represented my overall equation, work that Mary gets done plus the work that Antoine gets done, will equal the work that they get done in total. So, how much work do they get done in total? Well, they solve one puzzle. Now, how much work does Mary get done? Well, I know that that is going to be the rate that Mary works times the amount of time that she works for. So I'm going to label this R sub m for the rate at which Mary works, plus the rate at which Antoine works times the time that they work for. And now I'm actually able to input these values because I know the rates at which both of them work, and I know the time that they spend working together, which was 6 minutes. So there I have inputted now the expressions that I noted in the problem, and I have an equation that will probably look familiar to you. Solving this for t will allow me to answer my question in terms of the number of minutes that it will take Antoine to solve the problem himself. So go ahead and solve this either by hand or graphically and write out your answer, and then press play and check that your answer is not only the same numerical value but also is worded similarly, because that is equally as important. Solving this equation, I get two solutions. I check both of them and they both satisfy the original equation. That's good. And then I notice one of them is negative, and I remember that in context, this represents the number of minutes it takes Antoine to solve the puzzle. So I'm going to ignore the negative value and go ahead and use 8 as the answer. So working alone, it will take Antoine 8 minutes to solve the puzzle. Okay, now I'm going to give you a problem to try on your own, and then we'll take a look at your solutions tomorrow. All right, go ahead and copy this problem down in your notebook and follow the protocol that we have gone over to solve it for yourself, and we'll take a look at your solution tomorrow.